5, linearization and differentials. All right, linearization. If f is differentiable at x equals a, then the equation of the tangent line L of x is equal to f of a plus f prime of a times x minus a. Defines the linearization of f at a, the approximation f of x is approximately equal to L of x, is the standard linear approximation of f at a the point x equals a is the center of the approximation. So basically when we do these, we'll have the function, we'll take the evaluate it at the point that's given, then we'll do the derivative, evaluate it at the point, and then we'll have times x minus whatever that point is. To get our linearization. And then we'll do, there's a little bit that comes after that for like an approximation to see how accurate our approximation is, basically.
So basically you have a formula, you have numbers.
Correct. That's why I say this is
plug into formula,
way easier.
Get answer.
And so then, like, the answers to see how accurate our approximation is going to be like a 10 to a like negative power, like to like the -4 or something.
Okay.
And then that's going to be how we see how like good our approximation is. Obviously, the more zeros that there are to an extent, the better our approximation would be. Okay, then the other part of this section is differentials. Let y equal f of x be a differentiable function. The differential dx is an independent variable the differential dy is dy is equal to f prime of x dx. So just to give you a rundown of what this is going to look like. So do you remember when we went back, or when we were doing the stuff that was in the form, and the way we wrote the derivative was dy dx? So now basically what's going to happen is we're going to have y on one side, and then the other side is going to be the function. And so it's going to end up being dy is equal to whatever the derivative is times dx. And then they're going to give us a dx value that gets plugged in. So basically, we're going to take the derivative of the function, we're going to plug in x, and then plug in dx, and we're going to get a number out. So the hard part is the derivative. After that, it's just plugging in numbers. I took a whole differential equations class in college and loved it, and that's basically what this is. So, a lot of majors require, well, I say a lot of majors. Most engineering majors require differential equations. This is going to come when we get to some of the shorter word problems I was talking about, but just so we have this, sometimes we write df equal to f prime of x dx, where df is the differential of f. So instead of y, we use f, basically, is all that's saying. And those things can be swapped out. Like, those letters can be swapped out for other things. Like, if we have radius, it might be dr. Or if we're dealing with, like, volume, it might be dv or things like that. So anyway, so just more of like an FYI that it can be written another way.